So this is our next topic. So we are going to study about different coordinate system. The coordinate system is used to represent a vector in a space. So space can be oriented in a different way. You can orient space in a cylindrical form or a spherical form or a three-dimensional form where x, y, z are various coordinates. So there are three simple coordinate systems as per your syllabus, where vector can be accurately described based on its length, the direction, and in some cases we need to look at the angle and the projections. So what are the various the coordinate system which we can accurately describe about a vector? So let's start with the number one, a rectangular or Cartesian coordinate system, where we are using x, y, z system. The x, y and z are just orthogonal to each other. That means they are 90 degree each other. They are making an angle 90 degree with respect to each the axis. But in some cases the rectangular or Cartesian coordinate system may not be sufficient to represent a vector. So that cases, if you look at in that cases we are using another technique which is called a cylindrical coordinate system, where instead of x, y and z we are using three orthogonal vectors. They are rho, phi and z. So rho represent the radius of the cylinder, and phi represent the angle, and z represent the height of the cylinder. And in some cases even the cylindrical coordinate system is not even in the right position to represent a vector accurately. Example, just look at your coordinates in the earth, a GPS system. We are using latitude and longitude to identify a location of a particular space on the surface of the earth. So where we use a better way to representation of vector, we use a spherical coordinate system. So look at the spherical coordinate system. We can use r, theta and phi. So r represent the radius of the sphere, and theta represent the angle made by the radius with respect to that particular point on the surface of a sphere, and phi is another angle. So we will discuss about the details about all these various coordinates of various coordinate system detail in the coming lectures. And now here now look at the rectangular or Cartesian coordinate system. Here we have x axis, y axis and z axis. So this is x and this is y and this is z axis, and unit vector along x axis is ax, and unit vector along x axis is y axis is ay, and unit vector along z axis is az. The length of the unit vector is 1. Now look at a vector r. R is a vector. It has x, y and z coordinate system. We can represent r as, let us take an x component ax. This is the length of the vector r along the x axis, and a unit vector, plus y ay plus z az. Now let us see what is the unit vector along this direction, this r vector direction. So length of the unit vector is 1. Let us take this is a unit vector. This is along the r vector. So let us write it down as AR. AR is a unit vector, but it is acting along r vector. So AR can be represented as r vector by the modulus of r vector. So here goes the r vector. So what is the modulus of r vector? The modulus of r vector is, we have to take the square of x component, y component and z component and sum it and take the square root of the sum. So this is the absolute of the r vector. Now it is very simple. AR he goes here, X AX, Y AY, Z AZ, which is upon the absolute of the R vector. So this is the vector which is acting along the R vector. Its magnitude is 1. Its magnitude is 1. If you take the AR, absolute of AR, then its magnitude is 1. Now let us consider 2 points in a rectangular coordinate system or Cartesian coordinate system where x, y and z are the axis. The 2 points in a space are the P and Q. The coordinates of P is x, y and z, whereas the coordinate of Q is x plus dx, y plus dy, z plus dz, then the difference of P and Q is the difference of P. If you take the difference of vector Q minus vector P, then it is dx ax, which is along the ax axis, and dy ay plus dz and az. And if you take the absolute of this Q minus P, this is called the length of the distance between P and Q. The distance between P and Q. If you take the absolute of this vector Q minus P, then it is dx square plus dy square plus dz square. Sum it all together and take the square root. This will give you an absolute of the distance between these two vectors. Now this is called differential length, dl. dl is the length, small differential length, because the change is only very small, dx, dy and dz. So this is a differential length. Differential length. Then what is the differential area? Differential area. Differential area is, let us denote with ds, surface area, differential surface area. It is dx dy. We know that area equal to x y, so we should be careful when we use the cross. So x y, x z and y z. So length into breadth, same formula, the same method. So here if it is a differential, then dx dy. What is the meaning of dx? Dx means it is a very small incremental change in the value along x-axis is called dx. Dx may be very, very small. So the differential area is dx dy, that is also equal to dx dz, that is also equal to dy dz. Then what is the differential volume? Differential volume is x, y, z. This is the volume in the differential form. Let us dv is equal to dx dy dz.